Hey there everyone, welcome to our SQL journey. In this video, we are diving into the core concepts of SQL, that is, cardinality and relations. In SQL, cardinality refers to the uniqueness of data values in a column or set of columns within a table. It describes the number of distinct values that exist in a column and the relationship between those values. There are generally three types of cardinality: high cardinality, medium cardinality, and low cardinality. A column with high cardinality has a large number of unique values related to the total number of rows in the table. For example, a column storing unique identifiers like user IDs or email addresses typically has higher cardinality. Medium cardinality is the middle ground between high and low cardinality, where the number of unique values is moderate. Low cardinality. A column with low cardinality has a small number of unique values related to the total number of rows in the table. For example, a column storing Boolean values like true or false would have low cardinality. Now, let's look at an example to have a clear picture about it. Now, this is the table which contains the data of few users, the user ID, the gender, email ID, and country. If you look at the user ID column, you can see that it is a unique identifier, as each user can have only one ID. So, the cardinality of this column is 5. But as soon as we go to the gender column, you see that there are only two values, that are male and female. So, the two unique values that this column can only have is male or female. So, the cardinality is 2. So, it is of low cardinality. Now coming to email ID, you can see that all the email IDs are unique because one person would have one unique ID for themselves. So the cardinality here is as well 5, so it's high cardinality. Now coming to country, you can see that there are 3 countries, that is USA, UK and India. So for this scenario, we can see that the cardinality is medium. Cardinality is important in database design, query optimization and indexing strategies. Understanding the cardinality of columns helps in making decisions regarding indexing, which can significantly impact the performance of SQL queries. Relations. In SQL, relations refer to the tables within a relational database and the associations between them. A relation represents a set of related data entries organized in rows and columns. Overall, relations in SQL provide a structured way to organize and manage data, allowing for efficient querying, manipulation, and retrieval of information. There are mainly three types of relations, that is one-to-one, one-to-many, and many-to-many. Now, let's look into each of them one by one. In SQL, a one-to-one relationship between two tables means that each record in one table is associated with exactly one record in the other table and vice versa. This relationship is established using a common key between the two tables. For example, if we have a table which contains name of schools and another table which has names of principals, it's quite evident that one school has only one principal. So, it's a one-to-one relation between these two tables. One-to-many relationship. In SQL, a one-to-many relationship between two tables occur when a single record in one table can be associated with one or more records in another table. This is one of the most common types of relationships in relational databases. Each department in the departments table can have multiple employees associated with it, but each employee in the employees table belongs to exactly one department. This one-to-many relationship allows for efficient querying of data related to employees and departments. It enables tasks such as retrieving all employees in a specific department or finding the department for a given employee. Many-to-many relationship. In SQL, a many-to-many relationship between two tables occur when multiple records in one table can be associated with multiple records in another table. To represent such relationship, you typically introduce a junction table, also known as association or link table, which connects the two tables involved in the relationship. Now let's consider an example of a many-to-many relationship. Let's consider these two tables, students and courses. A student can enroll in multiple courses, and a course can have multiple students enrolled. This structure allows for efficient management of many-to-many relationship between entities in a relationship data. Understanding the relationships between tables, whether they are one-to-one, one-to-many, or many-to-many, is essential for creating efficient and effective database schemas. Similarly, grasping the concept of cardinality allows us to optimize our queries and indexing strategies, ensuring optimal performance and data integrity. As we wrap up, remember that mastering SQL relations and cardinality opens doors to endless possibilities in the realm of data management and analysis. So, as you continue on your SQL journey, keep exploring, keep learning, and keep pushing the boundaries of what's possible with data. Thank you for joining me, and until next time, happy querying.